Okay, so here's the second part of this video dealing with nonlinear equations. And again, remember what you're really doing is you're undoing the math. So for example, if I knew x was, I don't know, let's just pick 3, then I would sub in 3 and I would cube it first, and I get 27. Then I would subtract my 1 and I get 26. Then I divide by 2 and get an answer of 13. Now, obviously, 3 is not the right answer because it doesn't balance with 62. But notice the idea there is what I do first, second, and third. First, I cubed it. Second, I did what? Subtracted the 1. And then the third thing I did was what? Divide by 2. And so if I'm going to solve this equation, I'm going to do order of op backwards to undo it, okay? Because obviously x does not equal 3. And you don't want to sit here and guess and test forever. That would just take forever. So we're just problem solving by undoing the process. So the last thing I did was divide by 2. So the reverse of that is I'm going to multiply by 2. And I'm going to do that first. And I'm going to do it to both sides. And that's an inverse, so those are going to cancel. The x to the cube minus 1 is not going to be impacted because the dividing by 2 and multiplying 2 undo each other. So this part's not impacted. And then that's what, 124? Okay, so then the second thing I did when I was going forward was subtract 1. So now I'm going to add 1. So I'm going to add 1 to both sides. All right, and then the first thing I did was cubing it. Now, you're probably familiar with square roots, like unsquaring 5 times 5 is 25, or the square root of 36 is 6 times 6. Cubed rooting is when it's to the third power. So like, for example, the cubed root of 8, I put a little 3 there, is 2 times 2 times 2 because it takes 2 cubed to give me that. So the cubed root of 2 to the cube, those cancel, and I get my answer of 2. So it's the base when you do that. So like, for example, the cubed root of, I don't know, like 64, I would have to think about what times itself 3 times. So what to the what power, what to the third power gives me 64. So I know 4 times 4 times 4 is 64, or I know 4 cubed is 64. So the cubed root would be getting to that root, which is 4. So it's kind of like you're undoing instead of area, you're undoing volume. So for this problem, the cubed root, I'm not going to use a square root because I'm not squaring, I'm undoing a cube. So I'm going to use the cubed root and ask myself what times what equals that, and it ends in a 5, so that's a good hint. 5 cubed is 125, so that's 5. Now on your calculator, you should have some type of key that looks like x to the y or some type of root key. And usually what you have to do is type in like the 3, then you hit that root key, not the square root, it's going to have like a little x or something up there. And then you type in 125, enter, and it should give you that 5. Again, we can check our answer. So let's go back here and fix what I thought was the answer. So 5 cubed is what? This would have been 125. Minus 1 would have been 124. Divided by 2 would have been 62. So then I actually found the correct answer. So the correct answer would be 5. And I can check my answer to make sure that's the case. All right, why don't you go ahead and read example 2 and go back and try problem number 3 on page 375. And I will meet up with you in just a second. Okay, so this problem might be a little problematic because of that guy right there. Having the x in the denominator is a problem. So there's a couple things we can do. Number one, we could do it like we started class and do the reciprocal function. So we can flip the 64 and the x plus 8. And then the reciprocal of 1 is 1 over 1. So when I flip it, I still get 1. Okay, so I could just flip both sides. And again, I'm reciprocating both sides. So that's, you know, I'm keeping things even, I guess. And then I could solve this. To get rid of, let's see, in order of op, what would I do first? If I knew what x was, I would add 8 first, and then I would divide by 64 second. So that's the order I would do it if I was going forward. The problem is I'm going backwards. I don't know what x is, so I have to do the reverse. So instead of dividing by 64, I'm going to do the inverse. So I'm going to multiply both sides by 64. I get x plus 8 equals 64. Then to get rid of adding 8, I'm going to do the inverse, which is subtracting 8. So I'm going to subtract 8 from both sides. So x equals, is that 56? All right, and then let's check our answer just to make sure it actually is the right answer. So I'm going to take this 56, and I'm going to put it in where my x is, and then I'm actually going to do order of forwards to see if it works. So I have 56 plus 8. So notice I really do add first when I know what it is. So let's see. Yep, that does give me 64. And then I really do divide second, and I really do get an output of 1. So I know that 56 is the correct answer, that keeps it balanced. All right, another way to solve that, if you don't like that one, is remember when you have a single fraction equal, and I can make this a single fraction, there can't be any adding or other stuff, then you can't do this. But if you have a proportion, which is one fraction equal to another fraction, Daphne, my dog's whining here, I can cross multiply. Daphne, shh, no. Sorry about that. She's not listening very well, is she? I can cross multiply. So then I get 64 equals, and I get 1 times all of that. And technically you have to distribute, but again, 1's not going to do anything. But if it was, say, a 2 or a 3 or some other number, it would. Daphne, I'm making a video. Thank you. And so then I would, to get rid of adding, obviously my dog does not listen to me, x equals 56. So if you have a single fraction equal to a single fraction, you can do proportions. Otherwise, you could reciprocate both of these to get the x in the numerator and go from there. Again, that only works because you have a single fraction and a single fraction. So unfortunately, if you have an equation, let me give you an example, like 3/4 plus 1/2 x equals 7/8 or something like that, and maybe even an x down here, you cannot flip it. You can't do a proportion. You're stuck clearing the fractions. You have to do what you're given there. Okay, so this last one I just want to talk through here. Our number 4, if you look at this equation up here, x squared plus 2x minus 4 equals 0, it says try to solve it. The problem is there's x's in 2 places, and so really the only way to solve this would be to factor like the box, and this is not even a pretty one for the box, so you're going to get decimals. It's not going to be nice. So you can't just bring your x's to one side in numbers because you have an x squared and you have 2 x's and you have that minus 4. It's not going to work that way. But notice it's x squared. It has degree 2. So that means there are 2 answers. So if you go down and look at that chart, the book went ahead and subbed in like a -4 into the formula, -3.8 into the formula, all the way. They did a +2 into the formula. And so I want you to try to find, there's going to be 2 answers, or usually there's 2 answers when it's degree 2. Go ahead and try to find those 2 answers. And then look at the graph on the next page and see where those answers are in that graph. And then I'll be back in just a second. Okay, so our goal is to figure out when that, what was it? X squared plus 2x minus 4 equals 0. And again, to undo the box, your original would have had to been something times something that equals 0. And again, that's kind of beyond this class, but that's how you would solve it because it's multiplied out, and the inverse of multiplying something out is factoring it. But look at the chart. Our goal is to figure out when does it equal 0. And so if you look at your chart, when are these values really close to 0? So it looks like kind of somewhere in here about. And then let's see, where else is it 0? About somewhere between these two a little bit. Okay, so it looks like -3.2 is about the closest thing, in this chart, and yeah, probably about 1.2, but it's actually going to be probably a little more precise than that. All right, and then let's look at the graph and see where those points are on the graph. And again, our goal was to get perfectly 0, but the -0.16 was about as close to 0 as we can do. So let's look at the graph here in a second. Okay, so if you look at the graph, our goal is to know when it equals 0. So do you see how it crosses 0 right here? and then it crosses 0 right there. And I can use maybe the highlighter, that might be easier to see. So we're looking there when it crosses, and we're looking right there. And again, notice those are actually going to be the same numbers we get from the chart. So about, you know, maybe a negative 3.3, and you might be off a little bit. You might think negative 3.25 or negative 3.4. And then on the positive side, it looks like, again, 1.2. You might say 1.1. That's fine too. Because our goal is, when does that equation equal, give an output of 0? And so this has an output of 0. And this has an output of 0. So again, remember quadratic formulas. Do not mess that up on the test. Where's my cursor here? If you have x squared plus some other stuff, if your degree is 2, you should expect 2 answers. And remember, you don't always get 2, because, for example, if it equals 0, and again, I'm using my mouse, not my stylus, but pretend I have a curve, a parabola that kind of looks like this. Notice if x squared equals 0, it still just crosses at one answer. There's only one answer, because you can't have positive or negative 0. So, but usually your exponent tells you how many solutions you should have, real solutions you should have. All right, I'm going to end there, and I hope you have a good day.